Hello everyone! In this master's project it was studied the transmission spectroscopy using high-resolution spectra of an exoplanet which is an extrasolar planet. There are four major types of exoplanets: the terrestrial, the super-Earths, Neptune-like and Jupiter-like. This project focuses on Wasp-76b, which is a hot Jupiter, a subcategory of Jupiter-like planets. This method is used in transit planets and it can be useful to analyze the atmosphere of exoplanets. An exoplanet is detected in transit when it passes in front of its star, like an eclipse, reducing its luminosity. A portion of the light can be absorbed by the exoplanet's atmosphere, originating absorption lines in the spectrum. The data of Wasp-76b comes from 70 exposures of the espresso instrument at a very large telescope, which includes 30 detections in transit. The main objective of this project is to detect and characterize sodium peaks using the data flux and wavelengths. First, the time of the exposures is converted from modifying Julian days to barycentric Julian days using the system coordinates. Then, due to the Doppler effect, it is necessary to shift the spectra into the stellar rest frame. The exposure's flux will be divided by the flux of the exposure with the lowest air mass to obtain the graphic of the noise for each one. After that, it is important to remove the parts of the graphics with strong tellurical features. Finally, it is possible to fit the noise with a polynomial function of third degree, and the fluxes before the division were divided by that. It is obtained in the graphic named master out, doing an average of the flux for each wavelength. If we zoom in the graphic between 5890 and 5900 Armstrong, it is possible to see the peaks of sodium doublet. After the construction of the master out, the fluxes obtained immediately before that step must be divided by the master out to remove the star contribution. It was fitted each spectrum with splines, and all the spectra was divided by that to eliminate the Wiggles pattern, which are the sinusoidal waves formed after the division by the master out. Then, the wavelengths must be shifted to the planet's rest frame. It is observed in the graphic of the shift velocity as a function of the phase phi that when the transit starts, the velocity is negative, so the planet is getting closer to us, and when it ends, it happens the opposite. It is done an interpolation again to put all the exposures in the same wavelength group, and a weighted average of the exposures fluxes. This mean corresponds to the final spectrum named as master in. The two peaks of the sodium can be fitted with the Gaussian curve. With this fit, the significance can be calculated, which is the amplitude of the curve divided by the relative standard deviation, and with that it is possible to see the quality of the spectra, which is quite good because the significance is above 5 sigma. I hope you enjoyed, and thank you for your attention.